Hey guys, and welcome back to another video on the channel. In today's video we're going to be evaluating this integral. So the integral from 0 to 1 of the square root of x plus the square root of x plus the square root of x plus, and it goes on forever. Now I'll just draw all those square roots in. So it's like an infinite sum pretty much. Okay. So imagine this just goes on forever, and this is what we're going to be evaluating. Now, you're probably thinking, how do you even start a problem like this? There's an infinite amount of terms, and they're all like numbers to the power of a half, etc. You can't really expand it due to the nature of the order of the polynomial. Like, you can't really expand something like this or something like this because this is to the power of a half, etc. But what we can do is take a look at our function in a bit more of an ordered term. So let's just label this f of x is this function here. So the square root of x plus the square root of x plus the square root of x plus, and then just put dot dots there that indicates it goes on forever. Okay. Now what we can see here is technically this entire thing here is just f of x, is it not? It's equal to this guy here. Well, not the integral itself, the function inside the integral. That is f of x, is it not? So why can't we rewrite this like this? F of x is equal to the square root of x plus f of x. It's a bit weird to write, but that is true. If you were to keep going on forever, this is exactly the same as this whole thing here, which is really weird to think about. So what we can do is try and rearrange this to make f of x a subject of the formula. So what we're going to do is literally square both sides to undo that square root over here. So what we get is f of x squared is equal to x plus f of x. Okay. Now we're just going to move everything to the left hand side. So we have f of x squared minus f of x minus x equals 0. Now you're probably thinking this is a quadratic. However, instead of a variable, we have a function. So what we can do is literally do the same thing. So f of x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where we have pretty much this scenario here. Plus b of f of x plus c equals 0. Now, in this case here, my a value is going to be 1. Oh, sorry, I used a red pen there. That probably isn't a good idea. Let's use this one as a highlighter. Yeah. So 1 is going to be the coefficient there. B is going to be the coefficient here. Now, c, in this case here, is going to be negative x. Rather than a constant, it's a variable. So all we're going to do is literally substitute this stuff into here. So we'll have negative b, which is negative 1. So you have negative of negative 1 plus or minus the square root of negative 1 all squared minus 4 times a, which is that number there, which is 1, times by c, which is negative x. So put in negative x as well, all under this square root. Then put over 2 times a, which is 1. So what this means is f of x is equal to 1 plus or minus the square root of 1 plus 4 all over 2. Okay. 2x, sorry. Nearly forgot that. Righto. So what that means is we can replace this guy here with our infinite sum up here. So if I am a bit lazy and copy that integral rather than rewrite it again, copy, move that down here, and then I'll rewrite it here as well. So this integral here is equivalent to just this expression here, the integral from 1 to 2 of 1. Now, with our numbers here, we're only going to consider the positive 1. Because you see this plus or minus, this means two different functions. Because this indicates 1 plus the square root of 1 plus 4x on 2. Or it considers this one here, where you have 1 minus the square root of 1 plus 4x on 2. Now, if you integrate them, you're going to get two very different answers because these aren't the same functions pretty much. One is like a reflection of the other due to the sign of the coefficient here. But we're just going to consider the positive one because if you notice about our function here, x values can only be positive. Now that doesn't really have to do with anything of which one we choose to integrate, but we're only going to integrate one of these pretty much. And then you can find the other one very simply because all you got to do is chuck a negative sign from it. So I'm going to just choose this one here, okay? Yeah, and with this function here, we're assuming x is positive numbers because of this nature here. Because if you had a -1 here, then you'll have some complex values here. So I'm just going to rewrite this first positive solution here, and then I'll show you how you can find the second one as well. Alright, so what we can do is break up this integral into parts pretty much. So we can distribute the 2 to the 1 in here, so we get something like this. 0 to 1 of a half plus 1 plus 4x on 2 dx. Or if you wanted to, you could take the half out the front, so you can have a half of the integral of 0 to 1 of 1 plus the square root of 1 plus 4x dx. Okay? So, integrating 1, you're going to have a half, and that's going to be x. Integrating this guy here, we're going to do a substitution pretty much. So, let's just break this up again into a couple more integrals. So, we'll have a half integral from 0 to 1 of 1 dx plus this integral here with a half as well from 0 to 1 square root of 1 plus 4x dx. So what we're going to do is apply a substitution here because of the nature of this thing. Okay. So what I'm going to do is I'm going to let u equal 1 plus 4x. So in order to do this, I need to get rid of my dx and replace it with a du, because that's the variable we're integrating with respect to. If we were to make the substitution now, we would be integrating with respect to x, and it would just be rubbish. So we need to find our du, so we're going to differentiate this function, both sides, with respect to x. On this side, you'll have du dx, and on this side, you'll have 4. If you rearrange this, you're going to have dx is equal to du over 4. So the difference between the change of these variables is by a factor of 4, pretty much. So we can rewrite just this integral here as a half integral of square root of u du on 4. Now we've got to change our bounds pretty much because I'm not going to go back. So when x equals 0, plug that into here, u equals 1. So all I did was put the 0 here, so I had 1 plus 4 times 0, so it gives me 1. When x is equal to 1, put the 1 there, u will be equal to 5. So our new bounds is 1 and 5. Okay. This integral here is pretty much just going to be x from 1 to 0 times a half. So our answer will be a half. Okay, just for that value there. This integral, we can change up a bit. So we'll have a half, the integral from 1 to 5, of the square root of u du on 4. Now what we can do down here is literally take this 4 out the front door. So you can rewrite it as 1 on 8 integral from 1 to 5. Now the square root of something means that something to the power of a half. Just like how the cube root of something would be that something to the power of a third. So we can rewrite this value here as u to the power of a half. Okay. That makes it really easy to integrate now, because all you gotta do is add 1 to the power and divide by the new power. So you'll get 1 on 8, square brackets, u to the power of 3 on 2, divided by that, which would be 2 on 3, from 1 to 5. And now we don't need to change back to x because we changed our bounds of integration up here. So x is gone, and we just gotta keep this plus a half here, because that was our other integral we worked out before. Okay, so we have a half plus an eighth, and I'm going to put these big brackets because we've got to substitute 5 and 3. So you have 2, 5, 3 on 2, on 3, minus 2 on 1, 3 on 2, all over 3. 1 to the power of anything is 1, so all you're going to have is 2 on 3 pretty much here. Now if you wanted to, you can take out the 2 out of 3 if you wanted to, so you have a half plus 1/8 times 2 on 3 is going to be 1 on 12. So all I did was take out the 2, 3 and the 2, 3 out. So you have 5 to the power of 3 on 2 minus 1. 5 to the power of 3 on 2 will be, if you plug that, I don't know what that is off the top of my head, but if you plug in the calculator, I believe it's 5 root 5. So I'll just double check that. Yep, that's it. So we have 1/2 plus 1/12 multiplied by 5 root 5 minus 1. And that's probably the prettiest answer you can get for this, something like this, because of the third factor. So our integral here, I'm going to copy. Oh, I've already got copied. Never mind. This integral is equivalent to this. I hope you enjoyed the video. If you learned something, like and subscribe, because I'll be doing more videos like this. Thank you for the support on the previous video. Yeah, if you have any videos you want to take a look at, just drop a comment pretty much and I'll probably do it.